Okay, today we want to start with fraction. Okay, so what is a fraction? So a fraction is any number that has three things.
Yeah. Didn't you
So
what?
one of the things it has is the numerator, which is in the upper part. The numerator, then the dividing line, and the denominator. So if any number has these three things, then we call that number a fraction. So usually every number is a fraction. Every number is a rational number. That is, it is divided by 1.
Did you
So
what?
like when we say 2 over 1, 2 over 1 is a fraction, and therefore it's a fraction because it has the three things in it. Okay, so we're talking about fractions. So if we have examples of fractions are 2 all over 3, 1 all over 3, 4 all over 5, 6 all over 4, 7 all over 3. So these are examples of fraction. What about 1 whole number 1 all over 2?
That's a mixed fraction.
So we have the different types of fractions. So now this leads us to the three types of fractions that we have. So we have the proper fraction. So for proper fraction, these are fractions in which the numerator is less than the denominator. When the numerator is less than the denominator, it's a proper fraction. Like 3 all over 4, 2 all over 3, or 5 all over 7. Fractions in which the numerator is less than the denominator, they are called proper fractions. So improper fractions, they are fractions in which the numerator is bigger than the denominator, is greater than the denominator. Like for instance, 5 all over 3, like 7 all over 3.
But there's still one more.
9 all over 5. So these are examples of improper fractions. Looking at these fractions, we see that the denominator is less than the numerator.
But we
So
still.
that's why we call them improper fraction, right? Okay, the mixed fraction. So in the mixed fraction, so this is one in which the fraction contains a whole number. For instance, when we have 2 whole number 1 all over 3. So this is an example of a mixed fraction. Like 1 whole number 1 all over 2. It's an example of a mixed fraction. So as long as the fraction contains a whole number, we know that that fraction is a mixed fraction. Now, if you look at this very well, we will see that for proper fraction, it is proper and cannot be divided further. But if you look at the improper fraction, you see that it can still divide further. So, and we see that for the mixed fraction, it is the division that is what we achieve is that we can easily convert the improper fraction to a mixed fraction, and a mixed fraction can also be converted back to improper fraction. Like for instance, this 5 all over 3, it can be converted to a mixed fraction. So here, what do? We use this 3 to cut the 5. That is, how many 3 can we find in 5? It is 1. What is remainder? Remaining 2 all over the same 3. This same 3 that the denominator. So you can see we have been able to convert the improper fraction to a mixed fraction. On the same way, looking at this 2 whole number 1 all over 3, we can take this we can convert it to an improper fraction by doing what? Using the denominator to multiply the 2, and the answer that we get, we add this 1 to it. So it is going to be 3 times 2 6 plus 1 7 all over 3. So we can see that. So we can change this now. Looking at this now, if we want to take this one back to an improper fraction, what do? 1 whole number 2 all over 3. We want to take it back to improper fraction, we say 3. So we use the 3 at the denominator to multiply 1. That is 3 times 1 3 plus the 2, that's 5. Then all over the denominator. The denominator is always the same. It doesn't change. Now for this one also, if we want to take 7 over 3 back to a mixed fraction, so 7 over 3 is going to be 3 in 7. That will be what? 2 remainder 1, right? So that will be 2 remaining 1 all over 3. So this is how we change proper fraction to mixed fraction and mixed fraction back to improper fraction. Okay, so that's about that. So here we want to look at another aspect that we need to look at, just a side topic that we need to do before we continue our fraction. So this is called lowest common multiple, LCM. So if we have a set of numbers like 2, we have 6, 8. So these 3 numbers, we now want to look for the lowest common multiple of these 3 numbers. How do we find the lowest common multiple of the 3 numbers? So there is a a pattern that we use to do that. So first is we draw a table across the numbers. We will now look for the smallest even number. If there is an even number in the set of numbers that is given here, if there is any even number in that set of numbers, if you can look at this very well, we see that we have 3 even numbers. So which means just one even number can go in all the set of numbers that we have. Then we use 2 to cut all of them across. So at this point we use 2 to cut all the numbers. So we start with 2 cuts. So we use 2 to cut 2, it gives us 1. Use the 2 to cut 6, what does it give? It gives us 3. And we use 2 to cut 8, what does it give? That's 4. So this leads to another set of numbers again. The moment the number we cut is 1, we are done. It means we are no longer going to cut. So the numbers that we are going to concentrate is going to be 3 and 4. So between 3 and 4, if there is any even number in that, then we can still continue to use 2 to cut. So the next number we are going to use to cut now is still going to be 2. As long as there is an even number in that set, continue to use 2 to cut. So 2 in 3, if there is a remainder, it means it cannot cut it. So we take the 3 down, bring it down. So that means cannot cut it. Now 2 in 4, of course, is an even number. So 2 in 4 it will be 2. So this leads to another set again. As long as there is an even number in that set, continue to use 2 to cut. So here, do what? Use 2 days again. So 2 in 3, that's still going to be 3 because we cannot cut it without remainder. So 2 in 2 is going to be 1. So at this point, we have seen that this one has been reduced to 1. So at this point, we are done with this. The only set that is left after this is what? Is 3. This set. So since it is 3 that is left, still the same 3 that we will use to cut it. So it's gonna be 3. It's gonna be 1. So at this point, we are done with as long as get 1 under each of the numbers, then we are done. So the final answer is now going to be the multiplication of numbers on this row. So this row, this column, so we multiply all the numbers in this. Is going to be our final answer. So it's going to be 2 times 2 times 2 times 3. So the final answer is going to be times 2, 4, 4 times 2, 8, 8 times 3, 24. So 24 is the lowest common multiple of this number. So what that means when we say lowest common multiple, it means 24 is that number that 2 will go in it, 6 will also go in it, and 8 will also go in it. That is, if we use 2 to cut 24, so it means it can cut it without remainder. 6 can also cut 24 without remainder. Then 8 can also cut 24. So 24 is the lowest number. 4 numbers. 24 is the lowest number that these 3 numbers, 2, 6, and 8, can cut without any remainder. So that's the lowest common multiple. So now, what is now going to be the next multiple of this? Means if we continue to multiply this one with 1, 2, 3, so like if we multiply it by 2, it's going to be 24, right? It's going to be 48. Multiply by if it is 48, so it means 48 is the next number that the 3 numbers can cut without any remainder. So if you multiply that by 24 times 3, so that's 72.
Why is it lagging? This is also Why is it not working?
Just continue. And this is what? Don't erase this. Just, yeah, it's clear now.
Still,
Okay.
still gonna be 3.
And
3
cut 3.
30 is still it's gonna be 1.
So when everything is now 1, 1, 1, it means we are done.
Oh.
So what's going to be the final answer?
The final answer is gonna be 3. 3. Okay. Is
18.
8.
So 18 is the final answer.
Okay.
And that is the lowest common multiple.
Yeah.
It is the number that 3
Yeah.
will go in that number, 6 will also go in that same number, 9 will also go in the same number. So this is a new question. Which number are you going to start?
Yeah, I know that I see an even number. It's 2 or 8.
Good. And 8. They are
Yeah.
the 2 even numbers there. So as long as there is an even number, we're going to start with
2.
Okay, oh yeah.
2 and 2 cut 2 is 1. And 2.
How many 2 can we find in 8?
4.
Yeah, that's 4.
13.
Yeah, so this is gonna be 4. Okay, so the next line now is line.
Yeah.
Now you have this one is reduced to 1 already. So it's only left with, you are left with this and
yes.
this.
Should I use it? Okay.
So 9 and 4. So which number are you going to use to cut them?
2.
2.
I know why we don't use 1 anymore, because 1 is the lowest number and nothing can fit in it except 0.
No. As long as it's 1, just leave it alone.
Yeah, you
Or
just
if
don't.
you like, you can write the 1.
I don't want to write the 1.
Okay, now the next one you want to deal with is 9 and 2. So what do you do? What number are you going to put here? Put the 2.
We're gonna still use 2 because there's only one more even number.
Okay, oh yeah, continue. So now, what's the next number you're going
to? 3.
Well, because it's not competing with any other number here. So you just use the same 9 to cut.
Oh, the same 9?
Yeah, because it does not have any, there is no other number. So what is going to be the
But
final
I want
answer?
it to be slower.
So what is the final answer?
The final, I'm going to show you the final.
Yeah, so it's going to be 2
2 times 2
2
times 2 times 9.
4 times 2, 8 times 9, 72.
Yes, and that's about times 9.
Yeah, that's why it's 7. So it's the lowest common multiple. 72, 144, and the next number after that. As we continue to use 1, 2, 3 to multiply the 72. 72 is the lowest. All those numbers, 72 is the lowest. That is why we call this the lowest common multiple.
But why is it the lowest?
It's the lowest in the sense that 72 is that number. All these numbers, 2, 9, and 8, can cut without any remainder. Cut 36. If we say 72, now 72 divided by 9, what's going to be the answer? It's going to be 8, right? Not 16, it's going to be 8. Also, if you use 72 divided by 8, 2 divided by 8, what's going to be? It's going to be 9. Because we already know that 9 times 8 will give us 72. Right? So that's why we are getting all this. So these numbers that we see here, the multiple of it is what we're going to